Warm greetings and wishes to everyone. Today I am going to give the lecture on for rectangular body of length L, breadth B and depth D. He is subjected to the normal stresses Fx, Fy and Fz in all three mutual perpendicular direction x, y and z. So what will be the volumetric strain of a rectangular body if it is subjected to the tensile stresses in all the three directions x, y and z, and what will be the changes in the volume and changes in the dimension of a rectangular block. So before that, I will show the diagram and the notation what I am going to use it. Now we can see, so this is the rectangular block which is of length L, breadth B and depth D is subjected to the normal stresses Fx in the x direction, Fy in the y direction and Fz in the z direction. So due to these normal stresses on all three mutual perpendicular direction which is of tensile in nature, what will be the strain in the x, y and z direction? So that is given as, you can see, epsilon x is equal to the stress in the x direction Fx by me, where 1 by m is the Poisson's ratio for given material of the body, or you can put mu. So minus here Fx by E minus other two direction you have to put Poisson's ratio Fy by me minus Fz by me. Now you can see. Similarly, you can find the strain in the y direction and z direction, that is Fy by E minus Fz by me minus Fx by me. This is the second equation. And the third equation is, you can see, epsilon z is equal to Fz by E minus Fx by me minus Fx by me, where 1 by m is the Poisson ratio, that is, you can call it as mu also. Now you know what is the volumetric strain of a rectangular body. The volumetric strain of a rectangular body is the summation of the strain in the x, y and z direction. So the volumetric strain is equal to change in volume by original volume, that is the general equation. Now for a rectangular body, volumetric strain epsilon v is equal to epsilon x plus epsilon y plus epsilon z. Here all the linear strain, the x, y and z direction are subject to the elongation. That's why you are getting plus value. If any one of the compressive, you can put minus for the corresponding epsilon x, epsilon y, epsilon z. Here I have taken all the stress Fx, Fy and Fz are the tensile nature. If any one is compressive, you have to put minus the corresponding equation. So that is the algebraic summation of the strain in the x and y and z direction, that is the volumetric strain. If you substitute all these values, epsilon v is equal to epsilon x plus epsilon y and epsilon z, and you substitute, and if you are simplifying it, the epsilon v is equal to 1 by E, you can take outside, Fx plus Fy plus Fz into 1 minus 2 by m. So that is the volumetric strain of a rectangular body. So from the general equation, delta V, change in volume, is equal to epsilon V into original volume. So epsilon V is positive, means the increase in volume will take place. If it is minus, epsilon V is minus value, you will get the decrease in volume. So that is the thing. Algebraic summation of all the strain in the x, y, z direction into volume. Then again you are putting that volumetric strain or change in volume. If you are finding it, you can put it as changes in volume, right, epsilon v into volume. Epsilon v, you know that Fx plus Fy plus Fz by E into 1 minus 2 by m, and volume is Lb into D. So this is the way you can find the corresponding increase or decrease in volume, changes in the volume. Similarly, if you are finding the change in length, delta L is equal to epsilon x into original length, and you can put epsilon b, change in width by original width, that you can say epsilon z. So from that you can find the change in width, and change in depth is equal to, in the y direction depth is there, the y direction depth is there. Okay, we can find the changes in the depth. Delta d is equal to, right, epsilon y into the original depth. So you can find the corresponding changes in the dimensions also. So this is how we have to find the increase in volume or decrease in volume, or you can find the volumetric strain of a rectangular body if it is subjected to the normal stresses in all the three directions. Uh, so similarly, you can find the corresponding the normal stress either tensile and compressive in the x, y, or z direction. Accordingly, you can modify epsilon x, epsilon y, epsilon z, and also you can find the volumetric strain epsilon v. You can put epsilon x plus epsilon y plus epsilon z. So then you can find the corresponding changes in the volume. So if epsilon v is plus means increase in volume will be taken place. If epsilon v is negative value means so the decrease in volume will be taken place. So this is how we have to find the corresponding the volumetric strain and changes in the volume and changes the dimension of a rectangular body. Thank you very much for patient listening. God bless. வாழ்க வையகம் வாழ்க வளம்.